All right, problem number 5 asks, suppose x and y are positive real numbers such that x to the power of y equals 2 to the 64 and log base 2 of x multiplied, or to the power of log base 2 of y is 2 to the 7. What is the greatest possible value of log base 2 of y? This question is really begging, right, to use logarithms, right? We even have logarithms in the second equation. But this is slightly more complex, right? Because we also have the values x and y themselves. One way we can resolve this is to take logarithms, right? For example, it's probably a good idea to take the logarithm of this left-hand side, right? Not only to introduce logs into this conversation, but also to get rid of that nasty power here, right? So if we write log, of course, we're going to use base 2 because base 2 was used here. We get this. And we can see that on the right we get 64. And we can simplify this using the rules of logarithms. Remember that we can take powers out of logarithms to get this, right? And we can even write something nicer like log base 2 of x is equal to 64 over y. So now we actually have a nice expression for log base 2 of x in terms of just y. Let's substitute that into here to get 64 over y to the log base 2 of y equals 2 to the 7. And now, while we have a log base 2 of y in the exponent there, that's not very comfortable for us. So let's think about how we can get rid of that. And one way we can do that is, for example, to take logarithms, right? So let's take the logarithm one more time. We get log base 2 of 64 over y to the power of log base 2 of y is equal to log base 2 of 2 to the 7, which is just 7. But remember, we can take powers out again. And then we get log base 2 of 64 over y, which notice we can further simplify by remembering that log of a over b is just log of a minus log of b. So you have log of 64 minus log base 2 of y. And now the end seems to be in sight, right? Because this is just 6. So now, with all that information, we have an equation that's entirely in log base 2 of y, which, if we see here, that's actually a really good sign because we can directly now solve for log base 2 of y. Let's just say, let's just give this log base 2 of y some arbitrary value a and write everything in terms of a now. So you can see that log base 2 of y, right, becomes a. That becomes 6 minus a is equal to 7. And we once again have a quadratic equation that we can solve for a. I'm going to use difference of squares again. So get that a minus 3 all squared equals root 2. So a minus 3 equals plus or minus root 2. A must equal 3 plus or minus root 2. Right? So out of these two values, since we're looking for the largest possible value of log base 2 of y, we conclude that a must be at most 3 plus root 2, right? So our answer must be C.